Algebra 1, Chapter 3, Section 5, slope-intercept form, one of the most important forms that you will learn, and that is just a simple y equals mx plus b. In this form, m is the slope, and b is the y-intercept. Okay, where does that line cross the y-axis? The y-intercept. And so let's look at some specific lines real quick and take a look at their slopes. So if I had, oh yikes, if I had a horizontal line, okay, horizontal line, doesn't rise, doesn't fall, stays right where it is, this has a slope of 0. Okay, this has a slope of 0. Any horizontal line has a slope of 0. Okay, and so obviously with a vertical line, we're probably going to have a special slope as well. So if I have a vertical line, something like this, the vertical line has no slope. Vertical line has no slope. It is also referred to as undefined. Okay, no slope or undefined. What that means is it can't be measured. If you go to the top of a ski slope and you look down and you don't see the bottom, then you need to get away because there's no slope there. Okay, it's not a black diamond, it's not a double black diamond, it's a holy cow, where'd the mountain go type of deal. So no slope or undefined. So then we get into an actual diagonal line where we can measure the slope. And let's say I have this one right here. And so slope can be determined by a term called rise over run. So we determine the slope of a hill by where it goes from the bottom to the top. And so we need a couple of coordinates. So let's pick some coordinates that are actually on this line and they go at a perfect junction. So I'm going to pick this point here, and then I'm going to go down and I'm going to pick this point here. So how much do I rise and run? Now I can go from either point, it doesn't matter. But what I'm going to do is I'm going to do my rise first. I'm rising, and then I'm running over to this one. So in this case, from my first coordinate to my second, I rose, pardon me, I rose 5 spaces. And in upwards direction, that's a positive 5. If I were to go to a downwards direction, that would be a minus 5. Now that gets me to here. Then I go to the left. Let's see, that's 5, that's 8. 8 spaces. And because when I go left on the number line, that's a negative direction. Okay, so my rise is positive 5. My run is negative 8. So my slope is actually negative 5/8. And because my slope is negative, that means it's falling. If you have a negative slope, it is falling. Obviously, if that were positive 5/8, it would be rising. So it's falling from left to right. And a rising slope would look something like this. it would be rising from left to right. And so that's the difference. This would be rising.
Andrew Johnson, if you would willing, please report to the front office.
And I'll go back to the back one.
Johnson, if you would willing,
This one would be falling.
to the front office.
So they might ask you for the value of the slopes. They might ask you, are they rising, falling? What's the actual specific value? And so they might give you an actual, might give you a table. Let's go ahead and make a little table here. I'll go ahead and make that a little bit smaller. And so let's move that up here. And let's fill this with some coordinates. So again, they will give you these in the book. This is actually example 2, letter A. So my x values are 4, 7, 10, and 13. And then my y values are 20, 14, 8, and 2. Now, I could graph these on a graph and just do that rise over run that I just did, but obviously these numbers are a little bit crazy. And so there's an actual formula. The slope formula is the y value of a second point minus the y value of a first point over the x value of a second point minus the x value of a first point. Okay, so basically we're just determining a first and second point. So I'm going to say my first point is 420. My second point is 714. I could have picked any of them, it doesn't matter. Okay, so now I'm just going to substitute in here. What is the y value of my second point? And that's going to be 14. And I'm subtracting my y value of my first point, which is 20, all over the x value of my second point, which is 7, and I'm subtracting the x value of my first point, which is 4. So 14 minus 20 gives me negative 6. 7 minus 4 gives me 3. And then we always have to simplify our fractions. Negative 6 divided by 3 is actually negative 2. So I have a slope of negative 2. Now, we have to be very careful because we don't always get nice positive values. So let's just say, let's say my first coordinate, I'm just going to make some up here, is negative 4, 6. And my second coordinate is 3, negative 8. So now I'm throwing some negatives in there. Again, my formula, slope equals y2 minus y1 all over x2 minus x1. So the y value of my second point is negative 8. I'm subtracting the y value of my first point, which is 6. The x value of my second point is 3. I'm subtracting the x value of my first point, which is negative 4. Here's where it gets different. Again, I'm subtracting the negative 4. So that minus a minus means plus. Negative 8 minus 6, that's going to give me negative 14. And 3 plus 4 gives me 7. And when I simplify that, that is actually negative 2. So watch it when you have negative numbers. You could have, you could end up having minus a minus where you would have to put the plus. Again, that is a little bit of what's going on in the chapter. Just to finish it off, if I gave you something like this and I asked you to tell me what the slope was and the y-intercept is, Remember, that's y equals mx plus b. M is the slope. B is the y-intercept. In this case, pretty easy. The number out in front of the x is the 5. So my slope is 5. But there's not a value after it. So I could put a plus 0 there. It doesn't change. But that tells me that my y-intercept is 0. Now, everything won't always be in perfect y equals mx plus b form. Maybe we have something like this. Well, if I want to get that in y equals mx plus b form, I got to get the y by itself. So this takes us back to last chapter, or 2 chapters ago. I'm going to subtract 2x from both sides. That's going to give me 4y. Now in this case, because I want it in y equals mx plus b form, then I want to put that minus 2x first. Divide everything by 4. And so negative 2 over 4 is negative 1/2, so that's negative 1/2 x. And 8 divided by 4 is 2. So now I have a slope of negative 1/2, and I have a y-intercept of 2. And that is Chapter 3, Section 5, Graphing Linear Equations in Slope-Intercept Form. Actually, I want to take that one step further. I want to graph that one. I want to graph y equals negative 1/2 x plus 2. And so I have a slope of negative 1/2, and I have a y-intercept of 2. So I'm going to go on my y-axis, and I'm going to take my y-intercept of 2. And that slope, don't forget, tells me rise over run. So how do I rise negative 1? That means I actually fall. So I go down 1 and to the right 2. And I'm going to do that one more time. Down 1 and to the right 2. And now I have created, oop, I don't want a dashed line. I've created my line. So that completes Chapter 3, Section 5, Graphing using Slope-Intercept